Welcome back, everyone, to another monthly Ceph developer meeting. Make sure you're muted if you are in channel and have noise in the background. I think today is probably going to be relatively abbreviated. Our fearless leader is out and about. Last I heard, he was in Rome, so hopefully he is enjoying himself. I see a few things on the wiki tracker here. I'm going to post the overview doc in to the chat. It's also on wiki.ceph.com/planning if you didn't see it there. If you have anything to add, go ahead and feel free to edit and add it in here while we're chatting, and we will get to you. But I did say that Alan could start us off today. Alan Samuels from SanDisk was going to talk about the new encode decode framework and the BlueStore ONode serialization, deserialization stuff. So, Alan, you want to start us off, and then we'll keep rolling?
Sure, I can talk about that. I published a pretty lengthy description and some prototype code onto Ceph Devel. I guess that was a couple of weeks ago. And I think it's been observed that the CPU cost of the encode and decode is pretty high when you dig into the code, the way that it manipulates the buffers and buffer pointers and the iterators to the buffers. There's a lot of layering there, and there's a lot of code, and that turns out to be in the critical path of pretty much everything the OSD does. And as the other parts of the code path shrink, you start to see that overhead increase. But what drove that was the OSD ONode for BlueStore. The encoding for it is the simple encoding is pretty large, and what I did was to look at a number of pretty frequent special case optimizations and essentially create a flags byte for indicating that typical optimizations apply. For example, in the BlueStore ONode today, there's a logical extent map, which is a map of addresses and lengths. The vast majority of objects don't have any holes in them. So if you don't have any holes, you know right off the bat you don't need that pair of address and offset or length because one piece is adjacent to the next. So that's the kind of optimization that's being looked at. Essentially, the serialization optimization for the ONode doesn't really change any of the BlueStore algorithms at all. What it's really looking for is, a couple of typical optimizations like I just described, like where, there's no holes or where everything's in one physical extent, etc. Things that are not shared. For example, another field that's in the ONode is the mapping between the logical extent and the physical extent. There's an artificial identifier that serves as a logical pointer between the two. And it turns out that in the code, there's a distinction made between physical extents that are shared and physical extents that are not shared. In the case where the physical extent is shared, the pointer is global. There's sort of nothing you could do about it. In the case where it's local, it means that the physical extent isn't seen outside of this, and the actual value of the pointer is irrelevant. It's just serving to connect two different data structures together. And today, we're actually serializing that pointer twice, once at the spot of the reference and once at the spot of the definition. And if you sort of think about it in a clever fashion, it's very rare that the extent is used, that the physical extent is referenced by more than one logical extent. And therefore, you really only have one referencing pointer and one definition, and you can kind of arrange the serialization so that you get rid of that pointer on both ends. And the net of it is that I did some computations, and I'm sorry, I don't remember them off the top of my head, but we should shrink the ONode probably into the range of 8K to 6K for a randomly written 4 meg object, and that turns out to be sort of a sweet spot for Zettascale's usage in the key value store. So I was kind of rambling. Maybe I could get some comments from people. Or questions?
I didn't quite get I didn't quite understand it. I'm not quite sure what the relationship is between the buffer pointer in memory representation and the on disk format. I missed it.
Well, the O node, the extent maps in the O node are there's a separate logical extent map and a set of physical extents behind that, and the logical extents serve as pointers to the physical extents.
I see. Yes. Okay.
And when you serialize them today, you serialize all the logical extents, and then you serialize all the physical extents, and you have a bunch of references from the logical extents to the physical extents. And it just turns out that the vast majority of time, there's a one-to-one mapping between them. And if you sort of co-locate them, then you don't need to serialize the reference, because the reference value itself is arbitrary. So by,
that makes sense.
Essentially, you're encoding that information positionally. Okay.
Yeah. I'm sorry, I misunderstood. I thought you were talking about the buffer pointers versus buffer lists. Yeah, that makes sense. So you just change the encoding so that in the case that there's only one reference, you directly embed the physical extent instead of the logical extent.
Exactly.
Okay, that makes sense.
Yeah.
So do you actually expect that to hold true in, say, a real-life RBD deployment? And if not, are you like evaluating how much worse it gets?
Or actually, if you could back up, under what conditions do you have a logical extent reference with it, or does the physical extent have more than one logical extent reference?
So the situation where you get that is typically if you've had a large section that was written and then it got overwritten at smaller sizes. So, for example, if you say you write one big blob and then in the middle you write something smaller, you'll have two disjoint pieces that refer to the original backend store with the sort of overwritten piece in the middle. Does that make sense?
Yeah, that makes sense. So if you often have something like RBD where the writes are aligned for some version of that word, then they'll often overwrite whole extents. They won't often create holes.
Yes, I believe the holes case
I agree.
It's unusual. The encoding will handle it. It'll actually it'll be only very slightly worse than the existing encoding, but it's that I think is for a contrived case. For sort of any kind of case you would ever expect to see in the real world, it should be dramatically smaller.
Well, for the RBD case, if you have clones involved, then the first write to the clone will end up being a 4 megabyte copy from the parent in most cases, and then it'll start putting its new data on top of that in the smaller, block size chunks that you'd expect.
Right.
So in that case, would we end up having the problem that you're talking about?
Well, so in that case, what you're going to have, is you're going to move the blobs into being something that's shared amongst multiple objects. Okay, and the optimization that I'm describing doesn't apply, and you've wasted basically one bit in the encoding to indicate that this optimization is not being applied here.
Okay, that seems reasonable.
Is that everything for that one? Just a general briefing there, Alan, or are we setting on that one? Let you escape.
I'm sorry, what?
Is there anything left on that one, or are you good?
I think I'm good.
Okay, great. We'll move on to the next one. Make sure Jason is here. Jason, are you around? Dillerman? I don't see him on the list. Josh, do you know if he's kicking around somewhere?
I'm not sure. Let me check.
He's listed as being on PTO, but he's been sort of in and out of emails and BZs and things.
All right, we'll bounce past him for now. I see Michael Sevilla here had a blueprint. So Michael, you want to tell us about the MDS stuff, Mantle, the metadata load balancer stuff? Kind of introduce that and tell us what you're thinking.
Sure. Can you hear me okay?
Yep.
Awesome. I can't get my video to work, but I think we can go without that. So my name's Michael Sevilla. I'm from UCSC, and we wrote a paper last year called Mantle, which was dealing with some stuff in the MDS. We got that published, and then I wanted to get it merged into Ceph, and I talked to Sage about this, and he's on board, but the code was in a pretty unmergeable state. So I wanted to present a design document and kind of get your guys' feedback on that. So basically what we did was we looked at subtree partitioning inside the MDS. So this is all in Ceph FS. And we wanted to be able to control the policies in the metadata balancer and inside the MDS. And so we went in there and we stuck in a bunch of Lua hooks wherever policy decisions were made. And we were able to reuse the mechanisms and structures inside the MDS and just kind of exposing the policies, so separating policy from mechanism. So let's see here. We exposed this kind of raw ABI where administrators could inject Lua code to control the balancing, and we exposed this. We were able to replicate a couple balancing policies from other papers, and we came to some conclusions, and I put a link to the paper inside the Etherpad if you guys wanted to check that out. So like I said, after the publication, I tried to get it merged, and there were some problems or some concerns about how the balancers got into the system, where they were stored in the system, how the user invoked them, and I think there are safety, security, and implementation questions. So I basically broke that down into multiple commits. And in the Etherpad, I at the bottom at the top I gave a little summary. At the bottom I gave what the commits, how I actually broke them down. The first one is just writing balancer policies in Lua, and I think that's the biggest part, the hardest challenge in getting this thing merged, or if we wanted to even use Lua at all. The Lua code that you can inject into the balancers we neutered them down, so we took out all the libraries in the same way that I think CLS Lua did it. The second and third commits, we want to store a string of the version of the balancer in the MDS map, and then we also want to store the balancers as Rados objects in the metadata pool. So I guess I want to share my screen. Oh, it's having me add an extension. While I'm getting that set up, does anyone have any questions about any of that? Did what I say make sense as far as what we did and how we want to get this thing merged?
So I was just following along in your Etherpad, and I see the link to the pull request for the CLS Lua infrastructure, and there's a link to another pull request at the bottom which is closed. Is there currently an open pull request for the latest, the sort of 4 commits you're describing here?
No, I was going. So the first link that you said, the CLS Lua thing, I think Sage either added a submodule for the Lua source code or he pulled it into the tree somehow, and so I was waiting for that one to drop before I opened another pull request, because my stuff uses that same Lua source code, or it links against it. I figured to avoid confusion that would be better, or I can open the pull request right away if that makes it easier. Did that answer your question?
Yeah. So if you want to open it sort of preemptively, then feel free.
Okay, I probably can't. I can't open it. I can't open it right now, but I'll probably do it really, really soon. If that's cool.
Cool. Yeah.
I wanted to get the design out there before that, and then I was probably going to open a pull request after I showed the design. Hopefully, it would make more sense. Cool. So can you guys see my screen?
Yep.
Awesome. So the first time I showed this to you guys, you asked for some architectural changes. The one on the left is the SC, the publication. It was basically a hacked together. I went into the MD balancer and added all these Lua hooks, and I added them in weird places. And I think when I issued the pull request, it was really confusing as to what I did. So we threw hooks everywhere. And again, each of these even this box right here is all in the MD balancer, and I think it kicks out control to the MDS types to calculate metadata load. But the overall structure of what Sage designed in here is shown here, where it tries to make a migration decision, the balancer. Each MDS does this individually, and then each MDS will partition the cluster. Basically trying to figure out which MDSs it should send load to and which ones are underloaded, essentially. This third box is partitioning the namespace. So once it figures out which MDSs it wants to send load to, it'll figure out which subtrees it has that it wants to send load, or that it wants to send to a certain MDS, and then it'll fragment the namespace. So we added those Lua hooks. Those are the pink boxes here, and I added 4 of them for the paper, but I think that's relatively confusing. And so for the redesign, what we did is I essentially, from Sage's suggestion, essentially ripped out, or I kick off Lua much higher up in the data flow, or in the control flow, and it'll skip all the original balancer unless it's turned off, or if it fails for whatever reason. And so this was a much cleaner implementation. So the way that this Lua hook actually works is you get this the Lua code will get a table of metrics from the C++ code, and then it'll return an array of how much load you're going to send to each MDS. And if you return something other than an array of length cluster size, it fails and it falls back to the original balancer. So I think this is much cleaner, but I wanted to get your guys' opinion on this stuff. Is this design okay? From a default cluster, none of this will be turned on. But if you put the string in ceph.conf of which balancer you want to use, it'll start using the Lua stuff. And then from an architectural standpoint, is this going to encourage users from doing bad things or anything like that?
If I might ask, just at a higher level,
yep.
What is the virtue of putting this behind a Lua VM?
Just so we can, I think one of the things is we can change the balancers on the fly.
Yeah, so that's useful from a research point of view.
Right.
But why would you want that in a live system?
I don't think you want it in a live system. I think so. The problem we're trying to attack is relatively unknown as to which metrics affect what kind of balancers. So this is more of a debugging / figuring stuff out kind of tool. So I don't think you would want to turn this on in production systems, but we thought people in the Ceph community might want to play with this kind of stuff. Because right now, all those boxes in the MD balancer are hard-coded in there. And so they're a little hard to use.
That's true, but if you're in the community, you can always, rewrite them.
Yes, you can always hack them. I think we made it easier to understand what's going on by exposing a smaller API rather than going in there and hacking them.
That's fair.
But yeah, if you guys, if you go ahead.
I think given that context of who's going to be using this, the redesign seems like a big improvement to sort of minimize the surface area of the Lua stuff. If there's just sort of one place that we call into it, then it can sort of exist as its own thing for the people who are interested in it without interfering too much other places, which presumably is the whole idea of what you've done.
Right, and I tried to make it as unintrusive as possible, so the original stuff is still there. So if you don't turn it on, it'll never get activated. But from the Lua stuff, right? I know there were a lot of problems or a lot of issues that Noah had to go through with the CLS Lua as far as whitelisting classes and doing stuff like that. So I didn't know if I would have to do the same kind of thing here or any of that.
Hey, Michael, we had one user who was asking in IRC, kind of maybe you could expound under what circumstances the Lua balancer might fail. Like, would this maybe get in the way or cause problems, performance or stability or otherwise?
So if the Lua balancer fails, it'll just fall back to the original design. And the way that it's set up is this balancing logic, both the original balancer and the stuff that I did, is invoked by default every 10 seconds. So from a performance standpoint, it's not as much on the critical path because 10 seconds is a long time. If you changed the decision making to be faster, we might run into some performance problems. But for the most part, there shouldn't be any effect on the performance of, starting a Lua VM and interpreting code and doing stuff like that.
Can you expound on what particular circumstances might cause the Lua thing to fail? Like, why would it fail?
So if you put in code that's not valid Lua code, it'll fail. And if you try to return something other than what the C++ is expecting, it'll fail. But it fails gracefully. So it just kind of says, oh, well, we'll go back to the original balancer.
Gotcha. Okay, Patrick, does that answer your question? Cool. All right, thanks.
So you can still inject like while one, and it'll loop infinitely. But we had the same problem with CLS Lua, and from the last CDM, that didn't seem to be as huge of a concern for you guys because we figured the people turning this stuff on would be admins anyways.
Well, and you can do that with a regular object class. The reason for the whitelisting was simply that we wanted to make, before there were, the only object classes people were likely to create were either ones they went to a whole bunch of trouble to install themselves, or the ones we already include as part of the code base. So access control didn't really make a lot of sense. But with the Lua one, it can run arbitrary code. So at that point, you want administrators to be able to disable it. In this case, though, it sounds like there's a config option that just turns it on and off. So if the config option is not even acceptable, yeah. So that's
right.
I mean, to me, but I'm not
the key thing is it's being invoked by the MDS, which is already an admin-only thing. So it's not being touched by the clients. So I don't think we have the same security issues here.
Okay, that sounds great. If anyone has anything else to add, go ahead and stick it in the Etherpad, and I'll take a look at it, and that'll be great. And then a pull request will be forthcoming.
So at a larger level, oh, sorry.
No, I'm done.
I was going to ask, I guess this kind of means we're adopting Lua as our scripting language for stuff like this. Does that bother anyone?
I was about to ask that because I don't think we actually have any information on how it performs, which I wouldn't expect to be a problem. But
it's not particularly fast, but that's going to be true for any scripting language like this. It's not particularly slow either. It's fine. It's also the VM is also really easy to embed, so it's nice to work with in that sense.
Yeah, that sounds good to me. I just wonder because we do run it frequently, and so I wonder if we have just validated that isn't going to be a problem if it's invoked every 5 seconds or whatever. Because in particular, I'd like to get rid of our balancer once this is ready to go. Our balancer is bad.
Actually, more than a few platforms, there's a JIT VM that can be embedded if you're ready to go for that.
Yeah, but at a larger point of view, we already have C++, right? So that's with the object class stuff. You can either use the Lua thingy if performance isn't super important, or you can just link against the object class interface directly. So it's possible that
sorry, that is the right way to do it. I'm agreeing, but I was just answering the question that.
No, I was just pointing out that even besides that, it's possible that a future evolution of this, if you really do want to get rid of the balancer, is you introduce a binary interface of which the Lua version is one plugin, and then if there's a speed-sensitive one, you could have native code versions too.
Yeah, that all sounds good to me. I was going to say, Michael, I think you sort of skipped over what the balancer does, so maybe you can really quick sketch that out for everyone on the call who hasn't looked at that code.
Yeah, sorry about that.
And like the architecture boxes looked good, but can you maybe sketch in some of the broad integration points about like, it looks like you basically just replaced the balancer, which sounds great, but is it done in a way that we could pretty easily stick something else there if we wanted to do like C++ class balancers or something? Or and where is I think you said it's just an object in Rados is where the Lua scripting is done, but like how that's configured and set up?
Yes. Okay, cool. I'll attack those one at a time. So from a high level, I think most of us, I hope most of you have heard that you can have multiple active MDSs. So we're not talking about multiple MDSs where the back three are standby, but we're talking multiple active MDSs managing the namespace. And they use a technique called dynamic subtree partitioning to move essentially directories around the cluster to balance load. So we're talking about hotspots and flash crowds. So metadata load has a little bit of a different effect on clusters than data load. There's a couple different properties, mainly that a lot of times if one file is really popular, you can end up overloading a single MDS, and then it's hard to migrate that data, and you don't know if you should replicate it or shard it or do that kind of stuff. So that's why that was one of the reasons I think they designed Ceph with multiple MDSs, is because we knew that metadata scalability was a big problem. And so I think Ceph was one of the first file systems to actually make a clustered MDS, where essentially the MDS layer is essentially a cache over Rados, where it serves metadata requests really quickly. And so the balancer that Sage had in there, I think was still from his PhD thesis, but it was essentially this hard-coded metadata balancer where he made some ad hoc decisions about how to calculate load and how to decide where to send stuff and how much to actually send. And so we went in there and just stuck the Lua hooks in there so that we kept the same structure as what Sage did, but we exposed different kinds of policies in different places in the overall structure.
And it's stateful in the sense that there's state, but your system consumes the same state that the current balancer does?
So the original one did. The new one, I think you can re-implement what Sage did and recreate those states all in Lua. But the original one took Sage's overall structure and stuck Lua hooks in different places in his overall flow.
I meant so if you're making decisions about flash mobs, you probably need some historic information, right? So that stuff is already written out. I don't know anything about how this works, but that's written out in some sense in the fragment structure that the Lua class is given?
Yes, we could do that, but I just used a temporary file because that was easier for me. But saving state is one of the things that we want, and I think that'll be another design decision that we'll have to make.
Oh, I see. So you're writing your state out to a temporary file on the local MDS file system.
Yep, which is admittedly a hack, but
the MDS normally do.
I think it has this whole data structure that you can stuff stuff in.
The MDS usually, I think, is just keeping that state in memory for the lifetime of a given daemon. It sort of hit counts and whatever the field is called that tracks the temperature of a directory.
So it's okay if for different MDSs to have different date upon which they make decisions, because you're only ever making a decision for something you're authoritative for?
Yeah, they send heartbeats around, so they kind of have stale state a little bit, but they have a general idea of what the other MDSs are doing. But I think for scalability, they wanted to make independent decisions.
Yeah, so the default balancer is everyone makes the same decision about who exports where and approximately how much, and that's based off of the stale heartbeat information, and then the local MDS decides what to export based off of its up-to-date in-memory cache and the exact heat of things.
So the second question, Greg, I believe you asked, was what modules I would actually be touching. Is that right?
Yeah, and just sort of like, how is it hooked in? Is it, the Lua thing is active, so we skip all of the coded MD balancer? Or, like honestly, I have no idea where you wanted to plug this in or where it is plugged in, so I'm just curious.
Right, so most of the implementation on the right-hand side, for the redesign that we're talking about, on the right-hand side, most of it actually all of it, is in the MD balancer. And there's a little spot there's a function called prepare rebalance. And I just added a prepare mantle rebalance. And so if the Lua balancer succeeds, it'll skip all the original implementation and go directly to wherever the original implementation would finish. And then if it fails, it falls back to the original one. So it's all in the MD balancer for now. There's a couple other things that I wanted to touch, like in MDS types, but I'll save that for another pull request. For the paper, I just kind of went gangbusters on the MDS and touched a whole bunch of stuff, but I realized that if for getting this into Ceph, I'd have to be a little more structured in what I commit. So I was just going to start with this, just a Lua VM inside MD balancer. And then I forgot what your third question was, Greg.
Oh, I apologize. I haven't looked a lot at the pad, although I just sort of skimmed through it, and it wasn't clear to me. So, are you storing the Lua policies in Rados objects somewhere? And like, how does it get at those and specify them, or sort of what's the interface from an administrator's perspective and from a sort of data security access perspective?
Right. So the balancer itself, the Lua balancer itself, is stored in Rados, and then the administrator puts a string or in the ceph.conf or whatever through the Ceph CLI, saying which balancer to use, and then the metadata the MD balancer will go and pull it out of the Rados, out of the Ceph FS metadata pool. And so I guess the control flow for an admin would be 1, put your balancer into the metadata pool, 2, inject the string with the CLI, and then 3, the MDS will just start using it. All MDSs will use it, the same one.
Okay, so I think there was some discussion on this in the last PR, and I don't remember if we converged or anything.
That's
in particular,
so what I just
yeah,
what
okay.
I explained, what I just went through, that was Sage's idea.
Okay.
So I just went with that one, but
Yeah,
I do have another implementation that reads off the local file system. But
okay, yeah, no, it definitely needs to be in the cluster. I just in particular, we want to make sure that it's versioned as much as possible. So like the string shouldn't be a config. I think unless there was some reason we didn't want it to be, I think it needs to be in the MDS map.
So when you inject it with the CLI, it puts it in the MDS map.
Yeah, okay.
Sorry,
okay.
I didn't explain that.
No, that's
so
fine.
then yeah, we get all the PaxOC stuff. Yeah, so
okay.
Which is what you wanted, right? With the versioning. Okay,
yeah,
cool.
and we may also want to I'm not sure, but we may also want to sort of do some kind of snapshot or protected snaps thing the way RBD does for parent objects or for parent images.
Okay.
Although that's not something you need to work through right now.
Good.
I'm just thinking
cool.
For users for real, and hopefully we can wrap this all up in the Ceph Manager, John, right? So it's fewer steps.
So, well, I mean, yeah, maybe in Luminous, yeah. But sorry, just coming. What was it you were saying about snapshots, Greg? I didn't keep up with that.
Oh, I was just saying that we might like I want it to be protected as much as possible. I don't want an angry admin to trivially change the balancer and have different versions of the balancer running in different MDSs. Or I mean, accidentally, whatever. But I'm saying, like, you might want to take a snapshot and specify snapshots of the object.
Oh, okay. I was thinking, do we need to pass a version or a checksum around in the heartbeat messages so that if you got a heartbeat from somebody saying, I'm using the next version up, then you would have to wait till you have the latest MDS map or something like that.
Oh, that's a good idea, too. Ooh, I like that. I mean, probably it would again have to be in the maps rather than just heartbeat information, but yeah.
Well, it would have to be both places. It would be a version thing in the MDS map, and then you have your queue that you were behind if you got it in the heartbeat. But I wonder if we're over engineering this. If we buy into the idea that these Lua bindings are primarily for research rather than use in production, could we just not do this other complicated stuff?
Yeah, I don't think we need to do it to start with. I just, like I said, the balancer we have right now is bad. We don't have a lot of data about it, but we have enough to know that it's bad. So I would rather have one system, and as long as we have one, it should be configurable at least by us, and we want it to, be safe. So before it goes into production systems, it'll need some protection, but that doesn't mean it needs to happen right now. I'm just thinking forward.
Okay, yeah, agreed.
That's all I have. Unless do you guys have pointers to people anyone that's working on this or that I should be talking to?
Wait, one thing. Make sure it's covered by the experimental features flags.
Okay, I don't know. What does that mean? Or is that directed at me?
Yeah, there's a config thing.
Okay. Oh, I see. The yes, I really mean it thing.
There's a config list of allowed experimental features, and you should check that list before you allow the user to enable this.
Got it. That's what gets
the same way
in
that
VStore,
like
right?
that's the way BlueStore is hidden and some of the other experimental stuff.
Got it.
Just to make it
okay.
harder for someone to say, "Oh, that looks cool."
Well, we do also have the FS specific flags in the MDS map for things like allowing multi-MDS and snapshots and whatever. So it would probably slot in there.
That sounds good.
Oh, I have one last question, which is probably really annoying. Is there any plan for testing this?
Yeah,
having an automated test for it?
I have no idea how to do that. So if you could put a link to the Etherpad telling me where to get started because I was looking at the unit tests, I didn't see much on the balancing code, or I didn't see anything on the balancing code, so I might have just been looking in the wrong place. But yeah, if you could put a pointer in the Etherpad, and I'll start reading up on it and proposing how we should test this thing, that'd be great.
Okay, I don't know if I have anything to link you to, but I'll send an email.
Perfect. Thanks so much. And thanks everyone for listening to me.
Cool. Thanks, Michael.
Thanks, Michael. I'm very excited about this.
Cool. All right. It sounds like Jason. Yes, Jason is with us now. Jason, are you able to unmute?
Can you guys hear me?
Hey, there we go.
You
want to? Yep, sounds good. You want to start with your the RBD mirror horizontal scaling stuff?
Yeah. Let's start with that. Hopefully that's a simpler one. So the big issue right now that we knew going forward when we introduced RBD mirroring was that right now we only support a single daemon, which is not ideal in terms of high availability or also horizontally scaling the load when you have potentially thousands of images that you're trying to replicate. So we want to solve both those problems, and hopefully we can kill two birds with one stone. Fix high availability by basically adding horizontal scalability to the system. What I've drafted out here on the Etherpad is a phased approach that I like to take with it, and each phase adds additional features. So no matter what, if we only for Luminous only get to phase 1 or phase 2, we still have moved forward in progress with a system in a stable state, but also adding more features that for horizontal scalability or high availability. So at a high level, in phase 1, what phase 1 is going to tackle is basically the kind of bringing active passive to the daemon, where when the daemon starts up, they're going to try to acquire a lock. It's the standard CLS locking system to say like, hey, I'm the new leader in the pool. So whoever gets the lock acts as the leader of the pool. We're going to reuse the existing concept that we already use inside of librd for the exclusive lock. So if somebody has the lock and I want the lock, what I'm going to do is, if I'm another RBD mirror daemon, I'm going to go and check to say, hey, is that guy even alive? So I'll list the watchers on that file, and if it turns on that object, if it turns out he's no longer alive, I'll blacklist him and I'll try to take the lock, and I'll break the lock and I'll take the lock. So to help eliminate those situations. And I should also point out that just at a high level, I'm trying to push this all without having to do this with Mons, like trying to basically create a new like RBD mirror daemon map of like mapping who's responsible for what through the Mons. I'd rather hopefully just be able to accomplish this through RPC and the lock-in mechanisms that already exist within Ceph. Ricardo had a comment about whether or not we should just have. I propose that it should be one leader per pool or one lock leader per pool, because you could potentially be replicating multiple pools, and you could have different race conditions across different pools. So I was basically saying, well, if you own the lock for that pool, you are coordinating for just that particular pool. Another RBD mirror process could have taken the lock on a different pool, but he'll be responsible for coordinating the replication and assignments for all images within that pool. He was wondering, should it just be a single lock leader? The only way I can think of doing it without having to increase a lot of complexity, let's say I add a new pool that's replicated now, there's just a race about who becomes the lock owner of that one first, and now shutting down the, if it was a previous lock owner or something like that, it would be a hard problem to solve without just saying, well, we're just going to use this one pool named like .rbd mirror or something like that, and that's the only thing in that pool is just going to be that lock file that everyone's going to race for. So unless we went on a plan like that, I think it's probably still simpler and safer to just say it's a 1 leader per pool if you have multiple pools that are being replicated. I get into the details about what would happen in terms of like they'd also send out heartbeats for one another, so they would be able to check, well, the current leader hasn't sent out a heartbeat in a while, so again, let me just try to go acquire that lock. So it would follow the same code path to say, is he watching the file? If he's not watching the file, let me blacklist and break his lock and take the lock and become the new leader. So the goal is at the end of phase 1, RBD Mirror Daemon will support active passive failover, but there won't be any coordination or like splitting of the loads of saying this daemon is responsible for images A through M and the other daemon is responsible N through Z or anything like that. So that would be part of phase 2. For phase 2, we would basically have per image horizontal scaling. And we would do that through various RPC messages, which would be the watch notify RPC messages, where we'd have the ability as the lock leader to say, hey, I know about you, this other RBD mirror daemon, because he's heartbeating himself. He's telling me I know he exists, so I'm going to assign him 1/3 of the load or 1/5 of the load or whatever. So, phase 2 would be very simple. It'd just basically be like if you have n daemons up, each daemon would get 1/n of the load. So again, I listed some RPC messages that I think that we would need in terms of the coordination back and forth about saying, hey, I'm telling you to acquire an image, to start replicating it, and then it would act back with saying, hey, I've acquired it. Or if I want to take load away from an RBD mirror daemon, I as the leader could say, hey, release that image. And it would respond back saying, all right, I've shut down the replay on it. It's now fully released. Similarly, one of the
Jason, I think we're losing you.
states of RBD mirroring is if you have brand new images that are now being replicated, you have to do a full cycle. Hello?
Really choppy audio.
Hello? Can you guys hear me?
You're really breaking up pretty hardcore.
Can you guys hear me? Breaking up hardcore. Let me try to dial back in, and then if you see someone dial in, you can unmute me because I think phone's going to work better than internet.
All right.
Oh, back.
All right, we'll give him a sec to dial in here. If he's not immediately forthcoming, we can find something else. Jason, you back? Sounds like a Jason.
Yeah.
All right, let's see if the audio is a little better now.
Hello? Can you guys hear me? I just got an unmuted notification.
Yeah, there you go.
Okay, cool. Sorry about that. So the last thing I was talking about was the image sync process, which is where you have to pull a full image over. We also would want to coordinate that so that we wouldn't want, if we have a configuration value that's saying, limited to, we only want 5 concurrent full images to be synced at a time, the leader would also coordinate that with various messages about saying, hey, I've requested the ability to do a resync, a full image sync, and then the leader giving permission to start that full image sync. And then the phase 3 plan would be basically the hotspot ability scaling. So we would collect metrics. Each RBD mirror daemon would collect metrics about how many events it's replaying per second or things like that for its images. If it does it have a positive or negative velocity in terms of catching up with the journal? Is it falling behind on replaying a specific image? Is it perfectly caught up with an image? And it would periodically send those stats over to its pool leader so that the pool leader could collect those stats and make a decision about, hey, do I need to offload? This image X is getting high IOPS, and this one RBD mirror daemon can't keep up with that load plus the load of like 30 other images. So let me shed some load from that one RBD mirror daemon and spread it around so that it can concentrate on the high, the hotspot load. So these stats would be coordinated back to the leader. Those stats would be persisted to an object in the pool somewhere, so that if there's ever failure or anything like that, the current state of the cluster that the leader had decided would be available for when the new leader picks up and can basically start and pick up where the other one left off. So that's at a high level. And then I just at the bottom I have the nice to have, and this is something that I would fix also for librd for how it handles exclusive locks. Because right now, as part of that whole, someone already has the lock, but I don't know if that guy is alive or dead if I get it busy on that lock, so I have to go check to see if it's currently watching the object. And right now, the way we handle that is we put the watcher handle in the lock tag so that the other clients can say, hey, well, this current lock has got a watch tag of watcher XYZ, so I can go list the watchers and find out who that watcher is and see if he's still alive. Well, the only process to update that right now is to basically release the lock and reacquire the lock, which is not necessarily ideal. So if you have a situation where you've lost your watch because of a network hiccup or whatever, it would just be great to be able to update that tag of the lock so you don't have to basically lock and have that race condition of somebody else being the lock while you have it released. So we make that change. I'll also have it get that into librD's exclusive lock support too. Although it would have to support the old way of doing things and the new way of doing things if the OSDs are old enough that they won't have the new class method. So any comments, questions, concerns?
Answered everybody's question right off the bat. No one has any comments or thoughts on horizontal scaling RBD mirror stuff? All right, so I guess that was just a really good briefing. So Jason, you want to jump to the next thing?
Yeah. All right, so the next one's a little more controversial. So this is the librd client-side persistent cache, and the goal of this is to basically, if you have to basically offload loads from the cluster. If you have a high IAPS workload, it would provide write-back cache that is a local write-back cache to basically take that network latency out of the loop where you can preserve those and write those back to a local SSD, NVMe, or NVRAM type of backing storage. Similarly, it can serve as a read-only cache for your image. That would basically, if you ever have to restart your VM or anything like that, it'd be pre-primed to your working set. It could potentially be a lot bigger than, if you have a very full hypervisor and you can't dedicate, a gigabyte of RAM or something like that to libRBD's in-memory cache. This could be, you could offload it to your local client-side disk-based cache, and then all those reads would be served locally if possible. And then the third thing would be, when you have a lot of cloned images, they're all sharing the same parent image. It'd also be great to basically have a shared read-only cache where we could serve that, any requests, any read request that would be down to the parent image of a cloned image. It would be great if we could serve those locally instead of having to push it off to the cluster. So if you have, a bunch of VMs, they're all clones and they're all starting up for the first time or anything like that, you could potentially get away with no hits to your OSD, as if it reads everything from the local parent image cache. So just getting down into the high-level details, I mean, it's not a low-level detailed design about how this would work, but at a high level, the goal would be that this would be a plugin to libRBD. So this is not something that would be compiled into the libRBD code. It would kind of follow the same path as the EC plugins or there's some other plugins. We basically try to reuse the common plugin system of Ceph that is kind of sitting there in a PR form right now. And the way that we would manage this is that as an administrator, if I want to use this capability, I would have to do some pre-setup first, this one-time setup to basically configure my whatever device I'm going to use as my backing storage for this cache, be it an SSD, NVMe, whatever. And the goal we want to have here is just the concept of slots, where you're dividing this resource up into slots. There's I'll get into the possible two different design options. In the first design option, those slots are kind of just like a virtual concept of saying, well, I'm dividing this disk or whatever into 64 megabyte or 128 megabyte slots or whatever. The second design would basically require you to actually physically split these up, using LVM and creating logical volumes that would be slot size large. We would use a weighting scheme. So as an administrator, I would be able to say, hey, this VM, this is a very important VM, so he gets, he's weighted at, 5, whereas the lower priority VM would be weighted at 1 or something like that. So if you only had 6 slots available on your local cache, the one that's weighted at 5 would essentially get 5 of those slots, and the one that's weighted at 1 would only get 1 of those slots. In terms of client registration, I'm trying to keep it simple. I mean, here it would just be great if we could use just a standard file and use POSIX locking on it to guarantee that only a single client is modifying it at a time. So one of these libRBD client-side cache clients would go in, open the file, grab the right lock on it, basically register itself, saying, hey, I want to register myself to allocate some slots. He would write down, what's his weight total that he wants, some unique identifying features. If he had an associated parent image, he would make sure his parent image was also registered, or if that parent image was already registered, he would kind of already link to the registration of that parent image. And he would allocate himself some slots. Odds are that if it's a new allocation, probably all the slots have already been potentially filled up by other VMs, so he might have to, what's going to happen is that this is going to assume that everything is going to be cooperative. So he might not be able to get any slots immediately, but he's just going to periodically go back in and see if he can allocate some slots himself, because other clients, they're going to periodically check, and they're going to say, hey, a new client has been registered, and hey, according to, if I add up all the weights of all the clients and how many slots are available, that means I should actually deallocate one or more of my slots to get, free up space for this new guy. So eventually they'll get around to freeing up some slots, and eventually the other guy will notice, hey, now there's a slot that's freed up, and hey, according to the weighting, I should get that slot, so I'll yank that slot while it's free. So that's that's how we're going to handle it. We'll handle the client registration and the slot allocation. Again, just all local file using locking and just periodic polling of that file. So now the important part is how to store that cache data. So option A, and this is the option that Paige was pushing for. So for the read-only private cache option, where it's, this is my image, my private cache, each image would utilize basically just a sparse file. Where that sparse file would potentially represent, if you have a 100 gigabyte RBD image, your backing sparse file would be, sparse 100 gigabytes, but any extents within that file would be your actual data. So it's just it would just be a one-to-one mapping of, hey, if I'm trying to read from an image at offset XYZ, that data would, if it did exist in the local cache, would be at offset XYZ in that local file. And discards would be used basically to clean up that file when you have cache addition. We would also indeed have some metadata or something like that file to basically track, mapping of what's actually valid in that file. For the write-back private cache portion, so this is it would be a crash-consistent write-back cache. So everything that we want to put in is basically going to be journal events so that we can replay them in order, so that no matter what happens, if these updates are being streamed back to the OSDs, and something happens to that client, that persistent cache or whatever, your image is still consistent. It just might be stale by X number of seconds. So we'll have to have basically a file that would store events, the write or discard events. There'll be some potential for double writes, because if your read-only cache is actually caching the section that writing, you would have to basically update your read-only cache with the new data. There's potentially some possibilities we can do there in terms of, as part of our events to link, to say, hey, no, your data's not here with the event. It's actually in the private read-only cache. And if you overwrite some extent that actually is still dirty or something like that, you have to take that data and write it back into the event or update some pointer in that previous event to say, hey, now your data is located, here because it's no longer in the read-only cache. The shared cache, that's where things get a little more complicated because you're potentially having n number of libRBD processes all trying to read from and write data to this read-only cache for the parent image. So probably the only real solid way of doing that would basically be to have a daemon on the local host that coordinates that event. So if it opens up just like a Unix socket or something like that, that all these clients can connect to that daemon with and talk to. Preferably, we would do it so that none of the I/O would actually need to go through the socket. The only thing that we want to potentially have go through the socket would be control events saying, hey, do you have data for XYZ? And if you do, can I have a lease to it and tell me where I can find it? Or, hey, I just read this data back from the OSD. Do you want me to store this data, in the private cache? If so, give me a lease where I can, tell me where to go store that data in the private cache. So that's that. Option B, so that was option A, basically sparse files. Option B would, so instead of using the standard POSIX files, would be to reuse BlueStore. And as I was saying, option B would kind of require separate LVs, logical volumes per slot, because you basically would want to stand up a separate BlueStore instance per logical volume, because it needs, whoever owns the data needs to be able to write directly to BlueStore. I don't want to create another OSD to send I/O through to have it write all the data to disk. So if you're allocated more than one slot, you could potentially have more than one BlueStore instance that you're managing, which is potentially kind of complicated in terms of how do I put data in what BlueStore. It'd be great if there'd be some abstraction we could put in BlueStore where it could manage more than one physical device for its backing store. and manage the allocations across that. But then it would also need to be able to handle basically resizing. Hey, I want to add more devices to it, or hey, I want to take a device away from you, Blue Store, so that I can basically free up a slot to give to another client. The nice thing about potentially reusing Blue Store is that if there's any corruption or anything like that, Blue Store is already going to have all these tools for configuring, recovering, and things like that, these Blue Store volumes, and then potentially less work that we would have to do on the librvd side. The shrinking of a slot allocation would potentially involve double writes, because you would have to potentially move data from one device over to another device to get it out of that the device that you want to free up, the slot you want to free up. And then just one last thing I'll point out, and then deallocation. So a lot of people are going to be using this, okay, like pick OpenStack. They're not going to be nice about telling us, hey, this image is no longer ever going to live on this host or anything like that. So we need some way to be able to know that, hey, this image, don't ever expect this image to come back. So you can free up the slot that it's allocated for. So one of the things we can do to do that, to detect if the image has been, we can basically look to see if an image has been deleted or if it's running somewhere else. So if we know that the image has been deleted, or we can see that it's running on another host, we basically know that we're now safe to free up those cache slots for use for somebody else. So that's just a cleanup pruning job that other librvd client-side persistent cache clients can do on a random periodic basis. On behalf of the image that no longer exists on that host, that they will never start up again to do any cleanup. Again, don't want to have an admin have to go in there and manually free up slots.
It sounds like it might actually.
I'm sorry, go ahead.
That it sounds like it might actually be easier to have a daemon running on each client-side host bare metal thingy, responsible for passing out slots and garbage collecting ones that haven't shown up in a while. That way you wouldn't have all the librvd daemons trying to coordinate.
Yeah, that's awesome, because we're gonna have to have the daemon anyway for the shared case anyway. So you're right, it probably wouldn't make that much of a difference. Just have that one guy, or responsibility of that one guy.
So most of the data stored is for read caching, right? How much do you plan? How long? For how much time do you expect to allow something to do write caching?
I don't think, and this would be a configurable option, but I imagine it on the order of like seconds to low minutes, because that's the window of time that you could potentially lose all that data. So it's not like, hey, a one-day thing, I'll write back cache or something like that. It's basically to take the spiky loads and be able to smooth it out.
Yeah, so if you set it up that way, you could even allow the daemon thingy that's managing the storage, you could allow that to flush unstable writes before it frees up the space, even without the VM's permission. That means OpenStack would be able to deprovision a VM without actually having to wait for that to happen, potentially.
Yeah, so long as the only tricky race thing would just make sure that that VM would have to basically grab the lock and something like that, because you don't want that VM to grab somewhere else. But yeah, exactly.
That's already sort of true, right? Because you have to be able to tolerate unclean shutdowns.
Yep.
Do you expect like an administrator to need to intervene for you to be willing to forget about cached writes, or is that?
Well, so on the live migrate case, where basically there's the concept of, so if you have like your user level flushes, we can potentially ignore those. We can write them on the disk or whatever, but we don't need to basically say, hey, I'm going to flush this out. But on a live migrate, when QEMU basically says, hey, seriously, we need basically a hook from QEMU to say, hey, no, seriously, flush all this data out because this VM's going elsewhere. That to basically force all that data off that system. It would be something that would be needed.
Don't you need a way to distinguish between, a compute node dying and a VM being turned off and then turned back on elsewhere? That's what I'm not clear about. Do you just always trust OpenStack to put it back where it was, or do you enforce?
Well, so that's why you have the process saying, hey, is this VM running somewhere else? at that point, if it's running somewhere else, I can't flush the data off. I just have to discard all the data. There's potential, like, obviously there's a window.
So
there
until the shutdown completes successfully, it's still logically locked by that process? Okay, so this would be equivalent to an administrator breaking a lock manually on an RBD instance.
Yeah, I'm trying to. On the OpenStack case, I mean, I have to dig into that, like, what are the administrators? I mean, when you do a host evacuate or something like that, you get the data off, try to move the VM off.
Well, that's one case, but there's also so in that case, you'd have cooperation from the orchestration layer, right? But if the host actually dies, and there's supposed to be automation that allows it to come back up.
So if the host actually dies, and you bring it up somewhere else, I mean, yeah, but it's so long as the
so you're just
like, yeah,
at that point you'd just be relying on.
If it truly was down, you'd be safe basically that when it comes back up, that daemon or whatever would basically throw away that data if it sees that it's running, if that VM is running somewhere else, because it knows that, hey, this VM is never coming back here, or even if it does come back here, it's no longer going to be consistent to replay my journal data.
Okay.
But maybe we need some concept of basically like an epic or something like that about.
I'm not so much worried about the old instance coming back to life and rewriting it. I'm saying that up at the orchestration layer, something is handling compute node failure, right? So right now, they're probably very lossy about it. They aren't super worried about whether it's really failed or its network connection just got flaky. So they're probably not very conservative about relocating the VMs, right? But in this case, they would have to be kind of conservative because there'd be a user visible difference. They'd actually lose rights. Would that sort of thing require intervention, or would you push some changes upstream into OpenStack to allow the users to set policies on this sort of thing, or?
I mean, it's definitely a good point. It's something that we're going to have to think about. I mean, I don't know enough about OpenStack and that evacuation process. I mean,
from a usability point of view, it seems like
manual. I don't know.
Yeah,
it's been automated nowadays.
From a usability point of view, it seems like that's maybe the most important question. Like, yeah. That is, how do users expect that to be handled? Do they expect to, from time to time, just lose rights, or do they want that to require an administrator to intervene before they can lose rights?
Yeah, no, that's a good question, but that's something I can't answer because it's not my domain of expertise.
So maybe I missed something verbally about this, but I read the Etherpad, and it talks a lot about the slot allocation, and I'm having some trouble with that. Like, logically, yes, you want to allow certain VMs to have a certain amount of space, but it seems like for the write-back policies, which will surely have, like dirty age limits, and in addition to maximum space, and even for the read policies, then wouldn't that just all be like in software and not sort of impacting the physical disk allocation? Because it's talking about like having different blue store instances for each slot or something, and I just don't see how that works.
Well, you have
or
to realize
that's desirable.
like you have 100 different processes all trying to write something, so they're not all going to be able to write to a single blue store instance. So we're trying to coordinate in terms of how much space am I actually allowed to write before I have to start keep things from my cache, because I'm trying to be cooperative with other people that are other VMs that also have allocations on that host.
Is that actually more complicated than getting zero copy rights through to another process?
Yeah, like I just don't.
Put an OSD on the local host.
What? No. I'm saying you could have a single process manage the BlueStore instance and act as a server for the librd clients. The only catch is you don't want to serialize I/O through that, so you would need to do your allocations in a shared region.
I guess I'm missing what you're saying. You're saying still don't put the I/O through that path, but
you put the I/O through the path. You just don't serialize the data through the through a socket. You use shared memory, but yeah, you would signal the other process to do the write for you.
Okay.
That would allow you to use one BlueStore instance for all of them. It would also greatly reduce the cost of adding and removing RBD instances, right? Because you wouldn't need this slot allocation system. You would just like remember which client process is using how much data, presumably using collections or some such.
Yeah.
And you don't need to constantly create and uncreate BlueStore instances.
Yeah,
and that works a lot better.
If that process
base
ever dies,
images.
you've just deadlocked that VM or something like that.
Well, that's
was also
true,
my
but that's
concern.
equivalent to saying that a bug in the storage system deadlocks the VM, which is also true. I mean, you can create a supervisor process that will constantly recreate it and make sure that it's highly available in that sense.
Well, I mean,
But-
it can delete that for you. You don't need anything.
Well, you have to go a little further and make sure that it persists whatever state it needs to get back up and running when it comes back. But yeah. I'm not sure if it's feasible, but the multiple BlueStore thing seems complex.
And then I presume that we sort of don't expect people will use this with the RBD mirroring feature, or maybe we do, but is any thought, like how does the write back work? Does it interact with that in any way?
So it could work with mirroring, but it obviously wouldn't hit mirror. Right, if the write back would start kicking off to the RBD mirror journal.
Oh, one big advantage to having multiple BlueStore.
They would already be consistently ordered, and
One significant advantage to having multiple BlueStore instances is that they're different logical streams. So BlueStore right now doesn't do parallel streams the way you might want it to. That is, it only has one journal region in RocksDB.
what are you saying? Sorry, I must have something.
I was arguing against myself. I was saying the multiple BlueStore instances does have the advantage of helping you with parallelism. Since BlueStore does have a logical journal, so you'd be serializing.
Yeah, Sage was not super sold on the BlueStore, even though he was pushing for the Sparks file. Then you start thinking, more or less you're starting to create file store. I mean, it's not anywhere near as complex as file store, but in terms of performance or anything like that, you'll never be able to use, SPDK or something like that, in the long term because you're using standard files.
Well, and you have some advantages in terms of consistency. As long as you can match POSIX's irritating lack of consistency to the block device's irritating lack of consistency, you might be able to get away without a bridge layer like a journal, which would be a pretty big win.
Yeah.
But you're kind of gambling that there's no impedance mismatch between those two, which may not be true. I'm not totally sure.
Yeah, I mean, it definitely just gets more and more complex as you get journal events, like actually the events and things like that, and updating the read-only cache potentially at the same time as updating journal events and things like that. There's that interdependencies between the write-back cache and the read-only private cache.
I didn't quite follow. You're breaking up a bit.
No, I was just saying, like, in terms of if it was just the read-only cache or something like that, that'd be one thing. But you have the write-back cache that could be influencing what's in the basically the read-only cache. So there's definitely consistency guarantees that you need to be able to provide between those two.
Oh, you're going to keep them separate? They're not going to be integrated?
I mean, if you can come up, you have a good plan to keep them integrated. So basically, a journal, like a log structured file system.
Well, I mean, you would definitely need loci structures so that you could maintain the write-back order.
Yeah.
Is that what you mean? Because it seems like the buffers.
I was hoping to get them partially integrated, but you still have to have that ability. If I'm overwriting a dirty section that was still, hasn't been written back.
Oh, it needs to be multi-version. Yes, that's you do need multi-versioning. Yes, that's true.
Yeah.
Surely that argues for having a log structured write back, though. Or are
No,
you saying,
I think they're assuming a log structured write back and trying to work out what they need to do to the cache to make that work.
got it.
Yeah.
I mean, there's log structured and there's literally
log structured write back, but not necessarily wanting to use a log to basically do read replays if all possible for your read only cache.
I mean, if you just extend
why not?
Well, because you have to clean log segments.
Yeah.
I mean, it's kind of tedious, actually. Yeah. But if you have like a version concept so that your cache is multi-versioned, then I think it becomes a little simpler. Then you can link. Then you can still link the extents into a logical time structure elsewhere.
All right, does that cover off?
Yeah,
on
and that was my only concern about basically potentially like bringing up blue stars. Like, well, a lot of these like consistency issues have already been solved, and they would have been like hitting home, and you get all these fancy stuff that you would get with CRCs and things like that blue star will offer that we'll never want to recreate the wheel on.
Wouldn't it be nice if files could give you that stuff? But yeah, I hear your point. Yeah, I'm not totally sold on it either. Bluester is pretty complicated, and it gives up a lot for transactional consistency. You may not want to make those trade-offs.
You may not want to make it what? Sorry, consistency.
You may not want to make those same trade-offs. It really does give up a lot for transactional consistency.
Yeah.
All right, was that everything for the RBD stuff?
So Sam, Greg, any last thoughts? I mean, kind of left it up in the air about it.
I think that's all I've got.
Okay, cool. We'll take the rest to the lists and IRC then, and we'll keep rolling.
Yep, cool.
Thanks, Jason. All right. I guess next up is John. You want to give us a update on manager and the PG stat stuff?
Sure. So the status of Ceph Manager is hopefully reasonably clear for anyone who's followed the mailing list threads, and the pull request has been online for a while. So hopefully none of this is too new. The main thing I wanted to talk about is what shall we do with the PG stats and the PG map in the Kraken release versus what shall we push off till later. So one of the goals of Ceph Manager is to offload the big PG stats structures that aren't actually needed for the functionality of the cluster from them on. But Manager isn't going to be something that most people are running in the Kraken release, so they sort of need to stay in the mon for Kraken. And then at some point we need to have a plan for sort of splitting that out, and in the long run keeping only the stuff we absolutely need in the monitor, and leaving all the other stuff in the Manager.
Would it be possible to have an intermediate version where if you don't run your own manager, you get one for free and it's just started up by default with the monitor? And just don't tell anyone? No, really, because that allows us to solve the problem. We still get to test the code, and for users, it's deployed the same way. Whereas Manager have its own storage. I thought it was current. Oh, it does have its own storage. Crap.
Right, it doesn't have its own storage. So in the longer run, there's two things that need to be resolved. One is exactly where the split is between what goes in the mon and what goes in the Manager, and the other is giving the Manager the right storage hooks to be able to store its PG map so that it doesn't have to reconstitute it from scratch, which is what it currently does every time you start it up. So we could, I mean, we could do what you're suggesting and have essentially init scripts or whatever that start a little secret manager, and we could quietly pass through the CLI commands to the manager instead of the mon without telling anyone. I'm not keen on that because I don't think we're going to have time or opportunity to make manager particularly robust in the Kraken timeframe. The priority for me in Kraken is getting the interfaces in there, especially getting the Python module interface in there so that we can get people hacking on it and coding against it, rather than getting a very robust server.
In that case, I think PG stats go in right after L. I think that's the logical way to do it.
Right after we fork, you mean?
Because it doesn't seem likely that people are going to want to completely change the way they're deploying their systems between K and L. We'd rather have 2 full releases to do that. So we focus on getting the manager as robust as possible for L, but still optional. And then after L, we make it mandatory.
Oh, you mean actually after L?
Yes.
Okay.
Like right as soon as possible after L.
Okay. So
I assume we already have the infrastructure there, but
so I'm thinking about this, and I'm not sure if there's really much incremental we can do about moving part of the PG stats out optionally. Is there?
That's kind of what I mean. I don't think that's plausible.
Yeah, so
I think we can't do it until Ceph manager is mandatory.
Yeah, so the incremental part it's not incrementally moving things. It's going through a stage where they exist in both places. So, step 1 is you have a whole copy of your PG map in manager and also in the monitor. And then step 2 is at some point you remove the bit that was in the monitor, and now the manager is the authoritative place for it.
Forever inconsistent. That's kind of terrifying. I guess the whole idea is that they're allowed to be inconsistent. That's why we're putting them
exactly.
Yeah. I follow.
Hmm.
Okay, well, I mean, if that's a plausible way to go, then we can do it that way. Would we be setting up the command line tool to check whether this is a Ceph manager cluster, and if so, talk to the Ceph manager? Is that the notion?
So, yep, that's one way of doing it. You can.
Because that's the ultimate goal, right? We don't want to be proxying through the monitor. So
yeah, that's the ultimate goal. Yeah. So the way I'm looking at it at the moment in Kraken, you would probably only talk to the manager if you did it explicitly, and then in the point we start to make it a first class component, we would, I guess, have the command line talk to the manager in the first instance, get its list of commands, and then anything the manager could process it would, and anything it couldn't would fall back to getting sent to the mon. So the manager would be able to sort of quietly insert itself into that process. I don't necessarily want to commit to migrating all of the commands into the manager, because basically anything read-only is potentially going to be something that can move to the manager instead of the mon, because it can just read out of the copies of structures it has there. But I'm not sure that's particularly a priority if we can just proxy stuff to the mon whenever we feel like it. I mean, there is going to be a certain amount of messiness in these kind of intermediate.
Well, I'm not so much worried about the messiness. I'm worried about not testing one or the other. Having 2 things means one thing won't be tested. That's just the way it goes. And that's not good.
Yeah. So maybe we don't. Maybe with things like the PG map and also the health reporting, the health reporting needs to move to the manager at some point as well. That we aim to move them to the manager and test them in the Luminous cycle, and then make.
Yeah, but I'm saying if the mons also respond to these commands, we will miss tests.
Right, but we'd have to. Well, yeah. So what that would mean?
Rip them out of the
we would have to rip them out of the monitor. Yeah, and make the manager mandatory. Yeah.
Okay. I don't know. It seems better if we can hide the manager from people before they're ready to do separate deployments. People aren't necessarily going to want to do separate deployments of the manager anyway, so that's going to be a pretty important feature. What kind of storage does the manager actually need?
Well, potentially it can just use the mon for its storage. It can say treat the mon as its key value database and do things like dashing its copy of the PG map into the mon, which obviously puts some load on the mon, but it's just streaming a load of bytes in rather than having to actually run the PG monitor and that kind of thing.
And we can do that as an on upgrade step. The monitor would simply translate the on startup its PG map stuff into whatever the manager expects to find.
We wouldn't even necessarily have to do that. I mean, we could.
We could, and it would be easy. And then we could just run the manager as a separate daemon on the monitor nodes and not tell anyone. That gets us immediate usage of the manager. It allows us to make it mandatory immediately, and it allows us to gradually move stuff into it.
So when you say immediately, do you mean in Luminous? Or do you mean in Kraken?
Or Kraken,
okay,
whenever, whenever it's comfortable, right?
Yeah.
Whatever. But that way there wouldn't be this awkward period where there's this separate daemon that has to be set up separately, and it's only there if you bother to do the setup steps. It would always be present once we get to that point. That is, once it's in the code base, and you wouldn't have a choice. Everyone would go through the same code path. There would just be a distinction between whether it happens to be running on the monitor nodes or whether you went to the trouble of setting it up elsewhere. But that way we only really have to select one path with minor differences. There are two paths that are very different.
So how many user commands do we think we're going to route through the monitor or through the manager?
Well, anything new and high level would get implemented in the manager instead of the monitor.
But I thought that we really wanted everything that was already in the not everything, but most of the things that are in the monitor to stay there because then they work when the manager's down. Like I thought that was an important point.
Just the critical things. The only things we're allowed to move to the manager to begin with are non-critical things. Those it's okay if those don't. The manager is the repository of things that it's okay if they don't work for a little while.
Yeah.
So you would still have like the.
No, we don't need to fall back to the monitors. Is my answer. It would just fail.
That's not very many of the commands right now. And the way you were talking, it sounded like you wanted to move all of the commands through the monitor.
No. Just the ones that are going to go to the manager eventually. Good. This also allows us to start building features into the manager that we actually want without people having to actually do a separate deployment, which is pretty important.
I'm not sure how I'm not sure what the word is. I'm not sure how secretive we really need to be about the deployment.
You don't need to be secretive. You just need to make it so that they don't have to deploy a separate machine and that our build scripts and stuff all do the right thing.
Right. So it needs to be built into like Ceph Ansible and that kind of thing.
Yes, and not have to care.
The monitor startup, like the monitor and its scripts, should also start the manager if they're not configured to do something special. I would go that far. I would say administrators shouldn't have to deliberately start the manager if they don't have separate ones configured.
It feels a little hacky, but I can definitely see the motivation for it.
I'm okay with hacky as long as it saves us from having two places where some of these features exist.
Mm-hmm.
I really, really don't want to do that because I know it won't get tested. It's just not going to happen. People aren't going to use it because it's trouble, and people don't like trouble. And therefore, we won't get deployment in the real world, and that wonderful period where we're supposed to be getting user feedback, it won't happen. We won't get user feedback.
Mm-hmm. Sounds familiar. That sounds familiar.
I think it's worth awkwardizing the design just a little bit if it means that we can use it the same way at all the time.
Yep.
So anyway, the PG stats thing is sort of the challenge, right?
Well, actually, that's the thing. We don't do that until there's a manager that works.
Okay, yes.
And there's some other feature in it that people can reliably use because, again, we're always starting the manager, even if it's very minor. Once we're at that stage, it'll be much easier to move the PG stats. We'll have the code to move it into. We'll already have a test skeleton we can use, and we'll have a pretty good feel for what the manager can and cannot do. Right now, it's pretty abstract, right? And that's what's making it difficult to talk about the migration path.
Well, I mean, it's not that abstract. It sort of runs and
a little
works.
Because we're discussing even what does it mean if the PG stats move and we don't have the manager yet. I'm saying that's not a question that's worth talking about, in my opinion. I think it's better to have a manager that's always present, even if it doesn't advertise itself, That way we can just move forward with that as the only thing to worry about.
Yeah, well, so we definitely need to do that as of the Luminous cycle. But right now, the manager does have PG stats and does have a PG map in it. It's just that it's, that is temporarily duplicated, although there's not really any significant code duplication because it's using the same PG map structure and all that.
So,
yeah, and
John,
that's fine. And I think the next step is to make sure that that's always running in the monitor and then switch the Ceph tool to always use it. For those commands, for those specific commands, the ones that it's meant to handle. I think that's the next step.
Well, that and actually doing some more implementation work to get the PG stats being sent in a more efficient way, because currently it's just like a hack where it sends all the stats for all the PGs to the manager. It doesn't have like a queue for which ones have been modified and that kind of thing. So
yeah, sorry. So right. Oh, you mean the OSD does that, or?
Yeah.
No,
so
the OSD.
Okay. Yeah.
So the OSD, has its queue of which PGs have modified stats that it sends to the mon. Whereas currently the way it sends them to the manager is it just every n seconds it sends all of them, which is the same as the worst case scenario for the normal PG stats, in that if all of your PGs are busy, then that's what you were going to do anyway. So.
So with all this in mind, the discussion of making Ceph Manager a kind of always enabled sort of thing, provision, is it realistic to say that would land in Kraken, PG map, PG stats notwithstanding?
So nobody's planning on having it be an always enabled thing in Kraken. It's going to be experimental in Kraken. The discussion is how we go from that experimental thing in Kraken to something that's delivered and in use by users in Luminous.
Okay, so
can we really not get it done for Kraken?
I mean, it's not that much, right? It's just making sure that it's always running. We may not actually use it for anything, but it would be there. That's what I'm saying. I think we cut out a lot of uncertainty if we get to a stage where it's always there. And we can start relying on that. That is, we don't have to constantly code things to either use the manager or not if it's not there. That's what I want to get around. Right. I don't want to do that. I want to be able to just cut over from the one to the other, because even legacy systems already have the manager running. Like it's configured correctly. It's on the right platform. It's just that we haven't moved this thing over yet.
And I'm actually concerned about which interfaces might need to change in order to support the PG stats replacement entirely. Like maybe it won't be a big deal, but like I would want that to be in there before we really considered it worth anyone turning on.
No, I don't think that's true.
When you say which interfaces need to change, what do you mean?
Well, so I mean there are a very small number of things that the OSD monitor actually looks at in PG stats, and we have to decide if we just move those into somewhere else, or if the manager is feeding them back into the monitor.
I don't think we do. I really don't. No, I think that can happen once we have a manager that does one useful thing and is always on. That useful thing does not have to be the PG stats. It can be something else.
I mean, okay, but honestly, I think that's the first most useful thing it can do.
No, that's the most useful thing, but it's not necessarily the best thing to do first.
Okay.
I think if you couple those two things, you run into this really awkward chicken and egg thing where you want to use it for this, but it's not really present yet, and you haven't completely decided where it's going to be running and under what circumstances. I think if we make it do one useful thing, add that to the Ceph command line tool, and have it just transparently always contact the manager for that one useful thing, then it's easy to transition stuff later, comparatively speaking.
So so I completely agree about the one useful thing in terms of actually getting people to use it. It needs to do something useful.
I'm saying we're not even going to give them a choice. It'll be running. That's how this command works. If you want to use this command, it always goes to the manager.
Yeah. Anyway, the concern there is that in this intervening period where it's running but perhaps not being used as the authority for PG stats and things like that, it is still going to be sat there gathering the PG stats and using up
consuming resources.
I would argue no, because if the way it's doing that isn't the way it's ultimately going to do it, then there isn't much point in maintaining that code.
Right, but it needs the PG map in order to present it to the Python layer so in order for anything to
How inefficient is that? And can we just make it less inefficient?
So we can make it less inefficient. We will make it less inefficient. We must make it less inefficient. The question is whether we'll do that in the Kraken timeframe.
Because to be clear, there's a difference between the manager managing the PG stats and the manager reading the PG stats. Those are not the same thing. If the manager is simply acting as a client to the monitor in order to obtain the PG stats so that it can serve other things, that is not the same thing as the design changes that will need to be made to move the PG map into the manager.
Well, so the way
I think it's perfectly fine to do the one before we do the other.
So the way it currently is that the manager is getting the PG stats from the OSDs. It's acting as a server and it's being sent PG stats messages. So, you know, we could have, if we actually wanted to sync the PG map from the mon to the managers, that is also work because we don't currently have the interfaces for like subscribing to the PG map.
And I just don't see why we want it to be an optional deployment for anyone, even if it is feature add-ons. Like, if we want it to be a thing that everyone uses eventually, we should just turn it on.
I think we covered that part, but this is a more time thing. What do we do with the
PG stats thing? Like, you understand the manager does exist.
Yes.
Like, there's a pull request.
Except that it's not like used in any clusters, so no, in a larger sense, it does not.
Okay, but the code is there. There's a pull request, and like the one.
I know, but people can choose not to use it.
Thing that is materially easier than the PG stats, except that the PG stats requires us thinking about the algorithms, and I think that's a more useful exercise than anything else.
Okay, here's a good one. You could just have it graph the number of writes over a 20-second period. The monitors can't do that, or they could, but they don't. That's an example of a quasi-useful thing it could do using its information.
Yeah, but if it's doing that via some completely different implementation, it's not useful to us in the future.
It is though, and here's why. So let's assume for a moment that the OSDs are not sending it PG stats, and we don't have that detail, and all it's doing is reading the PG stats out of the monitor. This gets us over the deployment hurdles. It gets us over the how do we build it and package it hurdles. It gets us over the how do we set up the command line tools to read out of the relevant maps to figure out whether, for example, the monitors are running an older version and don't have a manager, or they're running a newer version and do. It allows us to get through the parts where it works out where the tools know where the addresses are. And all of that without having to worry about changing the OSD to monitor or OSD to manager PG stats protocols. We can do that second, right?
But I mean, what you're saying is that you want to strip back the manager to like half of what it is right now and add an interface.
No. So then hang on. So now that we unforget that we have the PG stats going to the monitor, then I would say we just continue to do that and base these commands off of that information and update it that way, because we don't necessarily want to rip it out unless we don't think that's the way we're going to do it going forward. But it still seems to me to be fine to do something pretty minor with the PG stats we're getting from the OSDs without having to go all the way to being the full authoritative source for PG stats. It seems like that's fine.
The one useful feature doesn't have to be PG stats either. Like, so the manager already has all of the perf counters from the daemons, and so it can do like giving you a lovely multicolored list of your OSDs with a list of their performance counters next to each one.
Yeah, that would be crazy useful. I assume that's being sent in the same message that they're using to send to the manager their PG stats, perhaps.
Well, currently they're actually separate messages, but
okay.
there's a M manager report message that MDSs and OSDs send to the manager, and then OSDs also have a hook where they follow it with a MPG stats when they send it.
Cool. Okay, so I mean, that sounds fine. So that command that generates that nice useful graph will always go to the manager and will always work, assuming the manager is running. And that seems like the right place to start. Then we can start teasing out exactly what sub-bits of the PG map can we afford to remove from the monitor entirely and allow the monitor to simply query the manager about them in non-critical things, obviously. If it's needed for something critical, then it has to stay on the monitor. And that's going to be a longer, more drawn-out design discussion. But once we have the platform, it'll be a lot easier to prototype stuff.
I mean, it will, but we do still have time in Kraken, and honestly,
not much, and that packaging stuff takes forever.
So I'd like us.
Gonna change.
Amen, Sam.
No, like, seriously, this stuff where you allow the admins to usefully turn something on and off, figure out whether it's running in the first place, deal with the fact that they're probably running the old version of the stupid init script because they just did an upgrade. Yeah, this stuff takes forever. It's a huge pain in the ass.
I understand it does, but like, that's not stuff that you or I or John is going to do, mostly. Like, basically what you're saying...
Someone's going to do it, and it probably has to happen before any useful work can happen, right?
Right. No, but I mean, but that is also fixed cost, is what I'm saying. Like, we're going to do that.
Yeah, and it's an important one that should be done early. It's not interesting.
That's fine.
I think we definitely do need packaging and init scripts for Kraken. That's, I mean, even though it's going to be, well, so I mean, maybe the way to couch it is that there will be this useful new command. It will be experimental, but it will be so useful that you'll want to use it even though it's experimental. And when you type this command, it'll go, oh, hey, you don't have a manager. Maybe you'd like to set one up, you know? So
yeah, see, that's what I'm saying. I don't think we should even give them the choice. We should set up the monitor init script so that it always starts the manager.
Yeah, but at that
command still experimental.
Okay, so here's the other thing is that when we do the PG stat stuff, then we're gonna have to like deal with upgrades.
Right. So this
rather
is
that we have, I want that testing to happen in Kraken rather than in the once yearly LTSs that the more production users are using.
So I really didn't want to commit to what we deliver in Kraken having stable interfaces for all the new manager stuff, because like most of this stuff so far, it's right off the top of my head. And I don't want, for example, a Luminous manager to have to work with Kraken OSDs. So, like, you know, maybe we go back and modify the manager report protocol to, you know, have smart data in, and we realize that something was wrong the first time around. You know, that's a very realistic scenario. So, I don't want to create the expectation for people that their managers from Kraken are gonna like carry forward into Luminous necessarily, and so that would be one reason to be less gung-ho about it.
Well,
what's the alternative?
What do you mean by carry forward? Like, do you mean in terms of data storage, or?
No, I want people. I want Luminous managers not to work with Kraken OSDs and vice versa, because I mean I know that's usually what we do for, you know, our real supported stuff. But that's why I'm leery about making manager, you know, supported.
Well, here's the alternative view on this. Let me go ahead and try and tackle this one. Okay, if you want to say you're going to get it right in Luminous, okay, well, I hope you don't get it wrong, because Luminous will be, you know, what downstream is going to want to support for 3 years, versus Kraken, which we're not going to take, and upstream supports it for a lot less time. So I think the gravity of the mistake is a lot less. I mean, there's a lower barrier to screwing things up in Kraken, and if we write it on the tin that we're not going to, you know, support this migration path.
Also, honestly, the OSD to manager data path is inherently lossy. It's inherently best effort. I mean, if we can't usefully degrade that over a one version upgrade, then I think the design isn't worth going forward with.
Yeah, I don't really understand.
I think, by the way, that we can.
It want them to say that they couldn't say.
Okay, I think we probably can usefully degrade it.
I know, that's kind of what I'm getting at.
It's more that the effort of doing that needs to be justified. And okay, maybe you are actually making quite a good case that the effort of doing it is justified.
It's been you know, we've been talking about this for quite a while. Eventually, you got to go for it.
Mm-hmm.
We won't know what design
works
right until it's mandatory.
Like if we decide that we did it wrong with those two messages, then we can keep the code in that parses them and like lose and have a lossy transformation. I don't.
Yeah. Okay. Maybe I'm making too big a deal of that.
I just don't see how this
I think you're making the right size deal about it. It's just that, you know, eventually it's got to grow up.
Yeah, and we do have to support whatever's in Luminous unless we want to wait a whole other year to make it required. Right. And
is there
it's got to go in Luminous.
Yeah, so that means to me that we really want to have enough confidence the interfaces are right in Kraken that like we're good. And that means
even if we don't have the confidence, we just want to have
just confident that we'll be able to handle the upgrade.
Well, okay, yeah, but what to me what that says is that we should do the PG stats thing.
The what?
What that says is that we want to have the PG stats thing in Kraken. To like demonstrate that all this stuff works.
It's a lot of work, and it probably won't make it. So we should probably
that much work.
we should still do the first thing first. Okay, well,
I mean,
that's fine. We should still do the first thing first. The first thing is to actually have the thing always running.
Agreed.
I will ask this though. Does the manager currently have persistent data?
Only a teeny tiny bit. So it exposes the config key interface to the Python modules. So at the moment, for example, the REST module has a couple of things that it stores, like its API keys go into config keys, so that if you start up that Python module on another manager server, it can still authenticate its users. Things like
And
that.
it uses the existing monitor storage for that?
Yeah.
Well, great. That's awesome. You don't even really have on-disk formats to worry about.
Yeah, I think maybe we can probably handle the versioning of the OSD manager stuff, because it is only a couple of messages. We should probably say for the moment that the Python module interface is a sort of internal to the Ceph tree interface, so it'll be a little bit like OSD classes. That
Yeah,
Cool.
You don't need to support old versions. I think ever. I don't think you ever need to support old versions of modules.
Yeah.
If external vendors want to ship things that hook in, that's fine, and they can version their damn modules every time we do an upgrade. In fact, I think we should make a point of breaking the Python interfaces every. I am so not kidding. It's not even funny. Seriously. Other companies and other users are going to build stuff on this, and if they get into a thing where they think they can just always ship the same Python, it'll be a big problem at some point when we change them. But if we change it every time, they'll get into a habit of packaging it.
Yeah, well, I want people to get in the habit of just putting their stuff in the Ceph tree for the most part, so that when we want to change interfaces, we can just change the modules that use them in one go.
Yep, exactly. Works for Linux kernel.
All right. So I think So I think the only that was mainly sort of choosing between things we'd already thought about. And the only sort of new thing there was the idea of putting something in the Mon packaging to sneak managers onto Mon servers.
Well, it doesn't have to. I'm not precisely sure how the packaging works. Maybe the right answer is that monitor depends on this thing. And if you don't configure it otherwise, the init scripts notice and start up the manager for you.
Yeah, I agree. We just need to work out how that's actually going to work.
Yep.
I've never written a systemd unit file, so I don't know what I'm talking about.
Me neither.
There's good news. Other people on our team have.
Precisely.
Okay, we should talk to those guys.
Do we only have to support systemd now? Is Upstart dead?
Yeah, Xenial is systemd.
All right, there you go. Now you only have to worry about one init system.
Well, until we invent the next one.
Well, that's not true. I mean, there is packages in the community where people are running stuff on FreeBSD, right? They don't do systemd.
That's totally their problem and not ours.
That's 100% their problem.
Don't care about them.
So yeah, I did have a ping from Tim Sorrell, who's interested in working on packaging. So I don't think this is the right time zone for him, but might be worth looping those guys into this whole story.
And to be clear, there's no way that no matter how badly the manager misbehaves, except possibly leaking memory, there's no way it can interfere with the monitor, right? The only I/O it does to the monitor in the first place is to put in those config keys, which is minimal.
Well, it's subscribing to the monitor as like a Liberados client, as a Mon client, subscribing to the maps. It's sending operations to get the daemon metadata when it sees the daemon addresses change. It's using the config key interface. There is also the manager monitor, which is running inside the Mon, which is the thing that notices the addresses of the managers and shares them with clients.
That's running whether the manager is running or not.
Yeah, and also
that's teeny.
So there's minimal risk here anyway. I guess the only real risk is that the OSDs, for whatever crazy reason, DOS the manager and mess up the monitor as a result.
Yeah, more or less.
The other risk, which is I agree. Super minimal is we expose some bug in Librados by exercising it more frequently.
Yeah, that's not so much a risk as a very good thing.
Right.
But I agree that it's a risk. We can minimize the memory leak one though by telling systemd to. We can do that,
Yes.
right? We can tell systemd
Systemd
to just
totally has
tell
that.
it if
Yeah.
it exceeds. Yeah. Yep. Perfect.
Yeah, there are lots of fun opportunities for leaks when you're converting C objects into Python objects, but
yeah,
yes,
but we
yes,
probably want to fix. We would probably like to fix those anyway.
Yeah.
So
Okay.
is there a good person who should, like, I'm happy to go through and audit the PG stats usage in the monitor, or do we want someone else to do that? Or I'm sorry, I'm really pushing on this. I think it's important.
Yeah, that's fine. I guess
just-
Kifu would be the other person to be interested in it, probably.
Okay. Okay.
But I mean, you would also be good.
Okay.
I'm happy to accept
We can
time
take that off the
donations.
Yeah. Or take that to the list then, yeah. The other reason I'm realizing that we want to do that actually is that we're going to have to test moving like OSDs from sending stuff to the monitors to the manager, and we probably don't want to do that in the next in Luminous for the first time.
Yeah, I agree. But I also don't feel that strongly about having PG stats fully switch over by Luminous.
Yeah, no, we want to do that, but we also need to support live upgrades from Joule to Luminous, which means that we're going to have to make sure the routing works properly.
Yeah, but no, I was saying I would like the PG stats to be in the manager by Luminous, but if they're not, I'm okay with that as long as the manager exists.
Yeah,
Okay.
I think we really want them in by Luminous.
I really want them in.
I do too, but that kind of means we want them in by. That kind of means we want them in by Kraken.
That's what I'm saying. I really want them in by Kraken, so that we can have them in Luminous.
I understand.
Otherwise, like, I don't really know how we force out the manager before whatever L plus 2 is.
Well, I guess the entirety of what I'm saying is I don't want PG stats to get in the way of getting the first steps done.
Yeah.
I guess that's it. I would like to do the first steps and then.
Well, yes, that's fine, but I think they're important enough that I will donate the time if no one else will to make sure they're done. So.
Fine.
All right, we are actually under 10 minutes left in our time. We can run over by 30 minutes, but we still have 3 things left. So we done with the Ceph manager stuff?
Yep.
All right, cool. So Sam, you want to give us a brief update on the EC overwrite stuff?
Since we're running short on time, I will say it's happening. The part where the missing set is persisted is done. We have some people at SanDisk working on a cache and the necessary changes to the hashing infrastructure, and someone writing a stub for file store to move. Those are in various levels of getting closer. I have been hip deep in reworking the structure that we use. If you've ever read Replicated PG Duop, you've noticed that all that mod desk stuff is really tedious and error prone. So I reworked it so that we can do that stuff on the back end in one fell swoop and remove all that code. So that's good. So work continues. We can talk more about this if there's time left.
Okay. Marcelo, do you want to give an update on the dedupe stuff?
Yes, I would love to. Can you hear me?
Yep.
Fine. Yeah, short about me. I'm Marcel. I'm working at the Zentrum für Datenverarbeitung at the University of Mainz. Last I was here was in April, and then we talked a bit about dedupe in Ceph in general. And the update I want to give is the last time we talked, there was like, yeah, I should start in from the back and see if and look at kind of a pool to store content addressed objects. And what I now did is I wrote a prototype for that, and I would like to explain a bit about maybe the architecture and about possible ways to move forward from there. The prototype is written in Python. I pushed it to GitHub, I think yesterday or today. It also has some kind of design document and the README, but let me give a short overview about it. Well, there is on the Ceph side of things, there is an object class that implements 3 methods. That's basically put, up, and down. Put puts a new object there and increments a reference counter if it's already there. And up and down are just for incrementing and decrementing reference counters. There's no get because for the prototype, I just use the regular Rados operations to get the objects out. What put also does is it adds metadata, like which compression to use, which fingerprint algorithm. Well, on top of that, there is a small Python library that abstracts those operations and adds the get and the list operation. It also does the fingerprinting. I basically throw data in there, and it gives me a fingerprint back. It does compression. It uses, I think, Snappy at the moment. And on top of that, there is a simple chunker implementation that right now does 4 megabyte static chunking. And it also manages kind of index objects, I call them. Those objects basically use the object map to map keys, which are kind of a version number, to the name of a CAS object that stores a recipe to reassemble this file at the end. So what you can now do is you have I wrote a small command line tool. You can like put me this tarball into a CAS pool, and it creates an index object, and I can find and I can reassemble this tarball by using this name. Yeah. The recipe objects are basically extend style. There's an offset, a length, and the name of the CAS object. So far, I ran some quick tests with storing my backups in there. I get, even with 4 megabyte chunks, I get usually around 20 to 25% reduction in storage, which is nice because it's not so much overhead it actually does, especially if you have kind of an archive workload. Well, yeah, from there, I'm thinking of maybe starting to rewrite the prototype in C++ and finish the points I left out for the prototype. In the GitHub README, there is also a list of limitations. That's basically the things I was too lazy about in the prototype to implement. Yeah, I would love to get some feedback on that thing.
Well, I went through the README and listened while you were talking, and it sort of looks the way I'd expect it to work. It looks so good job. I'm curious, do you have any any performance information or stuff like that?
Performance information. I can only give you like my from a rough test. Only one run, and I have my test Ceph cluster is like 2 machines with 4 OSD total. With Rados bench, I get about 80 megs per second, and with that thing, I get 15 to 20 megabytes per second. And well, it does all in Python. It does the hashing in the fingerprinting in Python. It does the compression. No, the compression is actually just a Python wrapper for C. But well, my guess is that in C it would be close to what I see without that added.
Cool. I mean, it all sounds good to me. I don't really know how people use these systems, so I can't really offer much deeper feedback, I don't think.
But what I'm thinking about is maybe this would make like right now. I think there is this on top of librados. Usually people use the striper thing, and this may be like an option to have like use like libcas or libstratos striper, I think it is, parity with that. But I think for certain application, it could be beneficial to have the choice.
Well, so I think the way the CERN guys are using the striper is actually underneath one of their object file systems. I don't remember which one it is. And so if I were doing something like that, I would sort of expect that you would want the index objects that you have here, but you would actually have something like caching them locally that didn't have to go out and fetch them in order to do I/O normally. Have you thought about, like, actually, I guess maybe the interfaces that are already here are exactly what you'd want for that? Or, well, no, I guess, have you thought about interfaces that would let you do something like that? Like, say, I have the contents of the index object and go do I/O, or?
No, not really. Or more or less. I mean, the indexes are pretty much exchangeable.
I mean, that does make sense, though, right? Is that because, like, you have two IOs right now, and if you already have a server in front that's doing some kind of backup functionality or whatever, then you have a natural cache point, and then you can get down to one IO in the common case. Like, or at least like when you're doing reads, then it's just the one IO.
Yeah, or ideally stick the recipe somewhere where I already have to fetch something, like in this head object in RGW.
Yeah, if you were doing RGW, that would be the right place to do it. Yeah, sounds great to me. I'd maybe try and connect with those guys, or if you were interested in RGW, then integrating with that would be probably a good next step to prove it out.
Mm-hmm.
I don't know what your end goals are.
I'm thinking about them. I know so far it's just like getting that production ready. And there's still a thing left for me. It's like when I write like 100 gigabytes and I'm writing all these cast things and I'm collecting the recipes for that. And at the end, I'm writing my index object. So if I happen to have a crash during that time frame, I would end up with objects that have at least like a reference count increased, and I could like have stuff lying around. And I'm not really sure how to deal with them properly. And my first idea would be like, well, I have some kind of recipes there. I could once a month, once every semester break, whatever, launch some tool that collects the recipes and then finds out if there's a file that's kind of abandoned and older than a year, throw it away.
Yeah, that's where sort of a central server comes in really handy. So RGW, unfortunately, the best we came up with was basically intent logging. But RGW has a similar problem where it has index objects that say what objects are in a pool and then the actual objects. And RGW handles this by journaling an intent in the index saying, hey, I'm creating this object right now. And it goes off and creates the object, and then it comes back to the index and says, now it's done. And if you fail at any point in there, then, like later readers can say, hey, there's this intent to create an object. Did that ever happen? And they can go off and find out if it happened, and if it did happen, and if it like got partway through happening and failed, then they can clean up the objects. And if it did happen, just not the index, then they can update the index. That's also a little unfortunate for something like this, which is why, like, if you might want to focus more on a centralized thing, or not, but like, or where you might have the intent logging on Rados, but really hope that you have a central server using interfaces that allow you to say it's done now, and then like that server can have its own local durable storage or something to deal with cleanups. I don't know, Matt or Yehuda, do you have thoughts? Like, if one was going to use this, then probably RGW would be the first natural place for it. No, they do not.
Yeah, well, no, I haven't been paying attention to the entire discussion, but we do have some kind of thoughts about revisiting the entire bucket index work now. So, it might be part of RAID's new architecture, but that might be something to discuss in the next CDM. basically the idea is we are replacing the whole button. Not completely replacing, but we're planning to add new ways to do the bucket index consistency. So either through lazy bucket index or through different methods of journaling. But don't know if it helps much.
Yeah, but basically, like to actually be safe, you would need some kind of two-phase commit, unfortunately. And then you could like have alternative interfaces that you really hope the people actually using it use, where they take responsibility for it.
Well, you don't necessarily need to do a two-phase commit for every operation, right? You can have like a window of operations or stuff like that, that you know that all operations that happen through that window are suspectable.
That's the case for RGW, but like where you're trying to provide an object abstraction like this is, then and it's just one IO at a time, then you really do need to add IOs. I mean, if you're worried about crash cleanup and stuff.
Right. Yeah. Well, you can write the objects in one place and then move them to a different place later on, or do something like that. So that if you find dirty data in one place, then it might be that you need, it's kind of like having a prepare not committed, or you need to think about it. But there's different ways to overcome that. But you will end up with more IO eventually anyway, right? There's no magic.
All right, I think we've got a few minutes left, right? Patrick, we should probably...
Well, we're a few minutes. We're a few minutes over, but that's fine. We've got until 3 as our hard stop. So we cover everything. Marcel, are you happy with where that's at?
Yep. Thank you.
Good. Then I guess the last one is David talking about the improved scrub interface stuff. So if you want to jump in there.
Is Alfredo not here?
Alfredo is not here. He asked me to move it to the next CDM.
Cool.
Hey, so by way of background, we, thanks to Kifu, we instrumented the scrub code and we we save off all the errors that we find, and users can run the Rados command and use librados interface if they want to gather this information to find out what objects are broken. The issue that we have something in a pull request right now, but one of the issues that we have is that it's very confusing. We try to compare, for example, the checksum of data between the different replicas in a replicated pool. And sometimes we're just picking an arbitrary copy as sort of the master copy, and then we're comparing it with the others. So you could have a situation where you have 3 copies, 2 of them are the same, and you just happen to arbitrarily pick the one that's different. And then in our algorithm, we would mark the 2 as bad, and we mark this third one as we could report it as the authoritative guess. And that's just confusing, and a human would look at those checksums and say, those 2 are the same, so the third one's the one that's broken. So anyway, I'm trying to figure out the best way to report this, so you can get a JSON output and maybe a human could look at it, or maybe some scripts, and they can figure out how to repair it. That's where I'm at. I don't know if anybody has any comments. it's complicated because there's also object info sometimes has digests. So that can actually, there are cases where you can know which ones are the wrong ones if that object info is available.
So operationally, how would you get at this information?
Either through a librados call or with the rados command, you get nice, pretty JSON output. Oh, and I was going to paste in, if anybody wanted to look, I have the current schema, which is not addressing this issue that I talked about, the authoritative copy and the confusion. It just shows you that it's going to list shards and then it's going to mark them with different errors. So wait, let me just paste that, the current schema. Anybody wants to look at that? That's the schema file in my pull request that I have right now.
If anyone wants to influence it for the purposes of like writing tools to consume it, now would be the time.
Yeah, so I think if people want to look at the schema and email me, or email Ceph Devel. Oh, one thing I am going to improve is that the object info from the arbitrarily or possibly arbitrarily determined copy is the only object info that's compared. And I'm going to enhance scrub so that we will look at the object info for every individual shard. So we might have a case where if the object info matches the, like in the case I was describing the example, two of the copies, they matched the object info and the third one didn't, then actually there's already code that kind of does that, and that's where it can be more assured that it will pick the best authoritative copy. So in that case, it would have an authoritative copy. So maybe I'm going down the wrong track on that. I think that would already work. But I did want to look at everybody's object info in order to flag a bad one. And we weren't doing that before. So that's all I have, unless anybody has comments.
David, it might be helpful if like next week or something when we have time, you might want to shoot an email to the list, just sort of summarizing, well, honestly, just with a link to that JSON, really. That'll give people time to sort of read it and give feedback.
That'd be helpful to get more context on the larger scheme of where things are and we prepare tools and what you can do now, what you're planning on doing more in the future with them. What will be automatic versus manual, that kind of thing.
Okay.
All right. I added a pad for the improved scrub stuff in the CDM tracker page. I threw your schema link into that pad, but if you want to throw down a few notes here as well, just so people have it for posterity, that would be great. But did anyone have anything else that wasn't on the tracker that they wanted to discuss? All right, that sounds like a whole lot of nothing. All right, well, we ran a little long today, but thank you everybody for showing up. I think we'll have another good one here, and I will post the video up on the YouTube stream within probably the next couple of days here when I get the opportunity. So thanks everybody for coming. We will see you next on the 7th of September. That will be an APAC friendly time, so it'll be 2100 Eastern time. So definitely keep an eye out for that one, or the October one if you're unable to make that that time frame. So we'll see you then. Thanks, folks.